Question 5. The region enclosed by the curve y equal x squared plus 1, the x-axis, the y-axis, and the line x equal 2 is rotated about the x-axis through an angle of 360 degrees. Calculate the volume of a solid of revolution that is formed. So let's do a quick sketch of the situation here. So x-axis, y-axis, the curve y equal x squared plus 1. This curve will be cut the y-axis at the constant there 1. So the graph will look something like that. So this is the graph of y equal x squared plus 1. 0 where the x and y axis meet. The line x equal to will be this line. So this is 2. Line x equal to cuts the x-axis at 2. So the region bounded, this is the region in question, bounded by the curve y equal x squared plus 1. The line x equal to this line, the x-axis and the y-axis, as a shaded region there. So the formula for volume is pi times the integral of y squared. We're going to integrate with respect to x, and the x limits here from 0 to 2. So the x limits here will be 0 to 2. Alright, so we need to find the y squared. Now y is equal to x squared plus 1. So y squared would be x squared plus 1 times itself. Y squared will be x squared plus 1 all square. That's x squared plus 1 times itself. So y squared would be, so x squared times x squared, that's x to the 4th power. X squared times 1, that's 1x squared. 1 times x squared, that's x squared again. And 1 times 1, that's positive 1. So v is pi times the integral of y squared, and y squared is x to the power of 4 plus x squared plus x squared, so plus 2x squared plus 1. So we're integrating all of this with respect to x. So we end up with v is pi, and the integral, integrating, add 1 to the x power, divide by the new power. So add 1, we get 5, divide by the new power, that's 5. Add 1, we get cube, so we divide by 3, and integrate 1. 1 is same as x to the power 0, so add 1 is x to the power 1 over 1, so that's just x. And the limits are 2 and 0. So continuing, volume, pi, and we're going to formulate 2 brackets. In one bracket, we're going to replace the x with 2. So 2 to the power of 5, that's 32, so that's 32 over 5, plus 2 cube, that's 8. 8 times 2, 16, so plus 16 over 3. Need some more space. And then we replace x there now with 2, so plus 2. In the other bracket, replace x with the bottom limit, which is 0. So as replace x with 0, everything there becomes 0, right? So what we have here is 32 over 5 plus 16 over 3 plus 2, so plus 2, and we can use our calculator for this. This is 206 over 15 times our pi, and remember it's volume, so units cube, or cubic units. Next, as a particle moves along a straight line, its displacement is measured from a fixed point O on the line. At time t seconds, the acceleration a is given by a equal 24t minus 14. Find the expression for the velocity of the particle given that when t equal to 1, v is equal to 3 meters per second. So we know the formula for velocity is the integral of acceleration with respect to time. So we're going to integrate acceleration, which is 24t minus 14 dt. So we're integrating it with respect to t. So v, so we're going to add 1 to the t power. So the t power here is 1, so add 1 to 1. We'll get 2 divided by the new power 2. Integrate 14. Look at 14 as 14t to the power 0, since t to the power 0 is 1. So integrate 14 as 14t, and we have a plus a constant. So find a constant. We're told that t is 1. Substitute t is 1. We're going to substitute t is 1 and v is 3. That will help us to calculate the constant. So replace the v with 3. If t is 1, then 1 square is 1. So 24 divided by 2, that's 12. Negative 4 times 1, that's negative 4 plus c. So 3 is equal to 12 take away 14, that's negative 2 plus c. So this means that 3 plus 2 is equal to c. So the constant is 5. So the constant is 5. So therefore the velocity, is 24t squared over 2, that's 12t squared. 24 divided by 2 is 12, minus 14t, plus the constant, and we know the constant here is 5, so plus 5. So that's our solution, expression for the velocity. Part 2, use your answer in B1. Find an expression for the displacement s of the particle given that t equal to 1 when s is equal to 10. So the formula for displacement is the integral of the velocity with respect to time. So displacement equal integral of velocity. Now the velocity was 12t squared minus 14t plus 5. So 12t squared minus 14t plus 5. We're going to integrate this with respect to t, which means we're going to add 1 to the t power and divide by the new power. So we have 12t, add 1 to the power, we get 3, divide by 3, minus 14t, add 1 to the power, we get 2, divide by 2, integrate the constant, is 5t, put our plus c. And of course, we are told that t is 1 when s is 10, so substitute t equal to 1, s equal to 10. So replace s with 10, we get 10 equal to 4t cubed, and of course t is 1, so it's just 4. Minus 7t squared, t is 1, so it's minus 7. Plus 5t, t is 1, so plus 5. Plus c. So calculating this, so 4 minus 7, that's negative 3. Negative 3 plus 5, that's positive 2. So if we continue up here, this is 10 equal to 2 plus c. Which means that c would have to be 8. C would have to be 8. So therefore, the displacement s is, this is what, 4. So 4t cubed minus, this is what, 7t squared plus 5t plus the constant, which is 8. So this is our solution for the displacement. Part C, the gradient function of the curve C is given by 7 minus 2x. So the gradient function, that's dy by dx, is equal to 7 minus 2x. If the curve passes through the point 3,8, find the equation of the curve. So we want to find y. Alright, so we're given dy by dx and asked to find y. Now normally how it works, if you have y and you want dy by dx, you differentiate. And if you have dy by dx and you want y, you integrate. So we have dy by dx, you want y, we integrate. So y equal to, I'm going to integrate 7, we get 7x. Integrate 2x, we get add 1 to the power, 2x squared divided by, we get 2, plus c. So it's 7x minus x squared plus c. We're going to substitute now these values to get c. So it's going to substitute x equal to 3, y is equal to 8. So replace y with 8, x equal to 3. So 7 times 3, that's 21, minus x squared. So it's minus 3 squared, so minus 9, plus c. So 8, so 21 minus 9, that's 12, plus c. So 8 minus 12 equal to c. So c is negative 4. C is negative 4. So therefore, the equation of the line is, equation is y equal to 7x minus x squared, and c is negative 4. All right, question 6. The heights of 35 children at a nursery were recorded to the nearest centimeter. The data is shown below. So we have, there should be 35 numbers. Display the data shown above on a stem and leaf diagram. So let's do our stem and leaf diagram. So let me do the stem over here, and then the leaves on the right. Alright, so the stem, so it seems the smallest number there is 61. So let me establish the key. So the key I'm using, is 61, means 61. So 6 and 1. Let me go column by, and it seems the largest number here seems to be 111. So let me, so 6, let me just 7, 8, 9, 10. Alright, so we want to put the numbers in ascending order, so we have to be careful. So I'll do the numbers by column. So 61, then we have 95 is somewhere in the middle here, alright, 71, 111, 108, so 8 will be somewhere down here, 118, 75, 103, 78, 67, 79, 76, 109, 94, okay, so I pause the video and just complete the stem and leaf table there. Notice each digit in the leaf represent a different number. So this each digit here is represent the final digit of the various numbers in the data set there. So what are we asked to find now? The mean, the median, the lower quartile, and the upper quartile. Now the median, in terms of the position for the median position is n plus 1 over 2. And remember, n is in the amount of numbers, was 35 numbers, so 35 plus 1 divided by 2. That's 36 divided by 2, 18. So the median is not 18. The median is the 18th number. Alright, so to get the 18th number, we count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So the 18th number there, that's 84. So the median is equal to 84. The lower quartile, what we call Q3, the median, we also call the median Q2, or mid quartile. Lower quartile, we call it Q1, or sometimes we say first quartile. The position is n plus 1 divided by 4. N is 35, so 35 plus 1, that's 36 divided by 4. And 36 divided by 4, that's 9. So the median is not 9. Sorry, the lower quartile is not 9. The lower quartile is a 9th number. A 9th number. So 1, 2, 3, 4, 5, 6, 7, 8, 9. So the 9th number, that's 75. So the lower quartile is 75. And the upper quartile, the position for the upper quartile, the position is 3/4 of n plus 1. And again, remember n was 35. So it's 3 times 35 plus 1, that's 36 over 4. So 3 into 36, that's 9. 3 nines, that's 27. So the upper quartile is the 27th number. So we know the 84 here was the 18th number. Alright, so 19, 20, 21, 22, 23, 24, 25, 26, 27. So the upper quartile, or Q3, is 103. So the upper quartile, or Q3, is 103. At another nursery nearby, the heights of children of the same age were recorded. The median was 79 and the interquartile was 24. Compare the characteristics of the two groups of children at the two nurseries and describe one distinct observation about the distributions. Alright, so in the previous, the one we just looked at, the median was 84 centimeters, and the interquartile range, by the interquartile is Q3 minus Q1, our upper quartile Q3 was 103, and our lower quartile Q1 was 75, which gives us 28 centimeter. Alright, so in turn, if you should compare the data from the two nurseries, what you'll notice is that the median height for the one we just calculate is actually greater than the median height. Alright, so one observation is that the median at the first nursery is greater than the nearby nursery. And the interquartile. And interquartile is just the spread of the middle data. So notice the middle half and so the median of the first nursery is greater than the nearby nursery, and the interquartile spread is also greater, and the interquartile spread, which represents, by the way, which represents what we call the middle half, was also wider than a nearby nursery. What's the nearby nursery? Have an interquartile of 24, and the original nursery has an interquartile of 28. All right, let's move on to part B. A bag contains 6 red marbles and 5 black marbles. So 6 red marbles and 5 black marbles, that's 11 marbles in total. During 2 rounds of a marble game, a student is required to randomly draw 1 marble without replacement for each round. Construct a tree diagram to represent this information. Alright, so let's start here. So let's do the first round. First round and second round. So in the first round, possibilities are red, R for red, and using B for black. And the chance of drawing a red marble, there's 6 red marbles, 11 in total, so 6 out of 11. Chance of drawing black, that's 5 black, total of 11. So the second round, again the possibilities in the second round are red and black again, red and black again. Alright, so this is a case where the first marble was red. If the first marble was red, we have 5 red marbles remaining without replacement. So now it's 10 marbles because the first marble was not replaced. So 5 out of 10. And since the first was red, we still have 6 black. So it's 5 black. 5 black. So it's 5 out of 10. Down here is the event where the first marble was black. So you will now have 4 black marbles and 10 in total, so 4 out of 10. Down here, still 6 red marbles since the first one was black. So 6 out of 10. So if we multiply, let's complete the table by multiplying along the branches. So 6 over 11 times 5 over 10. 6 times 5, that's 30. 11 times 10, that's 110. 6 over 11 times 5 tens. 6, 5, 30. So 30 again over 110. 5 over 11 times 6 over 10. That's 30 over 110. And 5 over 11 times 4 over 10. 5 times 4, 20. So 20 over 110. We need to just add and make sure all the total is 1. So 30 and 30, that's 60. And 30, that's 90. And 20, that's 110 over 110. So the total probability is 1. So our table seems to be okay. Use your answer in part B1 to find the probability that the marbles drawn are all same color. So the probability that all the marbles are same color would have to be the situation where both of them are black or both of them are red. So let's look at the situation. For them to be the same color, both of them have to be red. So red, that's 30 over 110. And black, that's 20 over 110. So either both of them red, 30 over 110, or both of them black, 20 over 110. So both red, 30 over 110, both black, 20 over 110. That's 50 over 110. So 30 plus 20. That's 30 over 110 plus 20 over 110. So that's 50 over 110. And of course we can reduce this to 5 over 11. Part C, given the two events A and B, probability of A union B is 0.7, probability of A is 0.3, probability of B complement is 0.6. Now, if B complement is 0.6, then the probability of B is equal to 0.4. Always remember, the probability of B plus the probability of B complement must equal to 1. So if B complement is 0.6, then B is 0.4. That's how it works. Alright? Calculate the probability of A intersect B. So the probability of A intersect B is the formula is probability of A plus the probability of B minus the probability of A union B. That's the formula. So probability of A, that's 0.3. Probability of B, that's 0.4. A union B, that's 0.7. So that's 0.7 minus 0.7. So probability A intersect B is 0. And when the probability of A intersect B is 0, it means that A and B are what we call mutually exclusive. In other words, A and B cannot occur at the same time. End of this.